Alright, so here in this video we're going to see the answer key to the mid-chapter 9 review. First part, identify the vertex and state whether it's minimum or maximum. Remember that vertex is either the top or the bottom of that parabola. This parabola is either making U-shapes like this or like this. And identifies just the coordinate points. So this is an x-coordinate of 1, y-coordinate of -3. And it's a minimum because minimum just means smallest. So you'll have a minimum if you're the bottom of the parabola. You'll have a maximum if you are the top of the parabola. This one's also a minimum. It's at the x-coordinate of 3 and the y-coordinate of -1. Alright, so graph the following by making a table and state the domain and range. So here's the function. And you might be able to view this easier if you also imagine that this is plus 0x and then plus 0. That way it fits ax squared plus bx plus c right here. Alright, and then every single parabola will start off with x is equal to -b over 2a. That helps us find the x-coordinate of the vertex. So here I plug in the b value of 0, a value of -2, and we get that 0 divided by anything is 0. So the x-coordinate of our vertex is a 0, and that's also the axis of symmetry. Alright, so that 0 is what tells me to take a 0 to the center of my table, because it's the x-coordinate of my vertex. And then to find this y-coordinate, to find any y-coordinate, you plug in your x-coordinate into the original equation. So I do 0 squared times -2, I get a y-coordinate of 0. Right, which tells us that our vertex is at 0, 0. Then to find the other values on the table, remember you are just counting up or down from your vertex. All right, and then with the vertex in the middle, this blue line here and this purple line here shows us that the two values linked by that, since they're on either side of the vertex, will be the same. So you don't have to plug in 4 values, you're just picking one of those linked up by the symmetry line. So here is me plugging in 1, getting a y-coordinate of -2. All right, here's me plugging in -2, getting a y-coordinate of -8. Then I get those graphed. Domain is always all real numbers, but that's asking about what's all the possible x values this graph will ever touch. Well, this thing will continue to branch out to the left and to the right forever and ever. Now the range, we often talk about it starting off as y in between two numbers, and then looking at the smallest and the largest. This graph opens down, so it'll go towards -infinity, and the highest spot it ever reaches is 0. We can put a line under that. Now the reason that you only see this component above is sometimes you will see the range listed as this, because if y has to be less than or equal to 0, that's technically already incorporating that it's going to be bigger than -infinity. So it's a little redundant to say from -infinity up to 0, because if you just claim less than 0, that covers every number headed towards -infinity. So you could see it either way, but if you listed it as the full version of -infinity to 0, you are correct as well. All right. This problem here, a relief organization flew over a village and dropped a package of food and medicine. Good for them. The plane is flying at 1,000 feet up in the air. All right, that's where we see this y-intercept right here of 1,000. And then we have the -16t squared. And as if you remember, that's going to be a gravity component. Gives the package height h above the ground in feet after t seconds. Graph the function. How many seconds does it take the package to hit the ground? So we know this green number, our c value, tells us where we are starting. Okay, so if we're hitting the ground, that means we're looking for our x-intercept. All right. So to find that, let me get this x-intercept erased. Alright, so on this here, to find the x-intercept, that means we're going to be laying right on the x-axis. right? And so we can see that's what this ultimately ends up being. That's why it looks just like this. To find the x-intercept, that is going to be at a height of 0. Right, and that's why I took the original equation and height is 0. Because if I'm at a height of 0, I'm laying on the ground. And then we wanted to solve for time. So we would subtract 1,000 from both sides, trying to isolate this t squared. Divide both sides by -16, square root. It's approximately, because there's a little bit of extra decimals in there. Now the reason after this square root we didn't have plus or minus in our answer is because there can't be a negative time component in a real world problem. Alright, so the negative answer won't make sense. We didn't mention it. Okay. Moving on. Alright, so this one wants us to find the equation of the axis of symmetry, which is just negative b over 2a, and the coordinate points of the vertex, which is negative b over 2a for the x, and then you take that value and plug it in to find, into the original equation, to find the y value. So on each of these, and I filled in some of the missing values, like this one has a 0x in it. You'll see me doing that formula of negative b over 2a. That tells us the axis of symmetry and the x-coordinate of the vertex. Then to find the y-coordinate, you'll see me plugging in that x-coordinate into the original equation. All right, and so that's how all three of these work. Here I did negative b over 2a, minding my negatives correctly. I get the x-coordinate, which once again is the axis of symmetry and the x-coordinate of the vertex. Then you plug it into the original equation, simplify, and you find that y-coordinate. Okay? Now don't forget, you have to do the exponent first. So that's why I get a positive 4, then bring in that negative to get that negative 4. Right? And then same concept here, negative b over 2a. This one happens to have a fraction in it, which gets a little confusing for some people, especially when it comes time to square the fraction. But just think 3/4 squared. It's just 3/4 times 3/4. Multiply straight across to get a 9 over 16. So a decent amount of fraction work there, but it ends up becoming a number just as well. And that's what those would look like. And I put mine in decimal form here for the vertex. You also could have expressed this in fraction form as 3/4 and 57 over 8. This looks a little intimidating, which is why I went with the decimal answer there. And if we are graphing this, we would want to graph the decimals anyways, because it's going to be easier to conceptualize on the graph. Alright, so here, graph the function, label the axis of symmetry in the vertex, state the domain and range. Remember, every single time these start off with negative b over 2a. Find your axis of symmetry. Still the x-coordinate of the vertex. Plug that x-coordinate of the vertex in to find the y-coordinate of the vertex. Okay? Now, remember the y-intercept is always 0, c, which is why in this one, it's 0, 1. And there's that y-intercept right here, 0, 1. All right, so what I did to graph this one was, we found the vertex. All right, we calculated this. We knew the y-intercept, 0, 1. Then I reflected it across the axis of symmetry. All right, so I didn't calculate this point at all. It's just the reflection of the y-intercept. So that's a very fast way to get points 2 and 3. Is you find your vertex, plot your y-intercept, and reflect it across that axis of symmetry. Now for domain and range, remember domain is always all real numbers. You might be more comfortable with this range as this, but as talked about earlier, this is technically redundant, because if we just say that y is less than or equal to 3, that's saying that y can go down to negative infinity. But if you want to list it out in the full version like this, to where you're saying it goes down forever, and then its maximum y value is here at 3, that's fine too. Alright, So a disk is thrown into the air with an upward velocity of 20 feet per second. Its height h feet after t seconds is given by that function, of h and t. What's the maximum height the disk reaches? Earlier that word problem had to solve for the x-intercept. Maximum height, though, that's us looking for a vertex. And then it asks us to talk about how long it took to reach the maximum height and use a sentence. Vertex, negative b over 2a. All right, we do some calculations there. This is the x-coordinate of our vertex. And remember, in this one, our x-coordinate is t for time. So that's why it took 6.25 seconds, our unit for time in this problem, to reach its maximum height. To find the 8.5, what we do is we plug in 0.625 into this original equation. Now it looks like here in my answer key I messed up on this number after I typed it in. I'm getting a 12.25, which would be feet. And this would be here a 12.25 there. All right. And to find that, I'd plug all this into your calculator at one time, pushing the negative button for this leading negative, not the subtraction button. All right. So this 9.3 portion here, solve each equation by finding square roots. If the equation has no real number solutions, right? No real solution. So the key concept on this is make sure you isolate your square root. This one's already isolated, square root both sides. Don't forget your plus or minus. This one here, and before I'm ready to square root, I had to clear out the 32. I had to divide both sides by the 2. Square root. Now 0 doesn't get a plus or minus because it's just 0 either way. That would be an example of one solution. And here's one with no real solutions because by the time I isolate my square root, by subtracting 28, dividing by 7, I'm looking at x squared is equal to negative 4. And if I try to square root this, it should make sense that no two numbers that are itself can ever give us negative 4 because it'd have to be positive 2 and positive 2, which doesn't work because that's positive 4. And neither would negative 2 times negative 2 because that would also give us a positive 4. Right, so there's no real solutions for that. And then this one here, add 49 divided by 16. Square rooting a fraction freaks people out, but it's very simple. Square root the numerator. Square root of 49 is 7. Square root the denominator. Square root of 16 is 4. Don't forget your plus minus, and you're good to go.